Hutama Karya is one of Indonesia's leading state-owned company enterprises, with capital asset of $9.1 billion in 2021. We have many incredible infrastructure from road and highway, dam, building and until power plant. One of Hutama Karya project is the Indonesian Geodiversity Area Project, located in Kebumen, Sambung, Indonesia. This educational building has three main buildings such as Geodiversity Building, Geoconservation Building, and Dormitory Building.
In this project there are several challenges that we must solve, such as the project location in a mountainous area, difficult access to the project, time-consuming material mobilization, expansive soil, and owners who are in other provinces. This makes BIM a solution to solve the challenges of this project. In the application of BIM in the Indonesia Geodiversity Area Project, several dimensions are used: 3D BIM, which is used to create models and also clash detection, 4D BIM, which is used for progress animation, 5D for material takeoff, 6D for engineering analysis, and 7D for CDE and handover. On the construction stage, by making the 3D models, we can create such as 3D visualization, clash detection, material approval, BIM shop drawing, and 3D mock-up document. The benefit using 3D BIM are such as reducing rework due to clashes, better communication with other stakeholder like management, construction and owner, and various other benefits such as shop drawing production speed increase up to 150%, and material and shop drawings approval time is up to 1 week. BIM 4D will produce scheduling to control the construction progress to avoid the project delay, so the project can determine suitable methods and resources for priority work, so that during the rainy season, we have already entered the architectural and MEP works. And we can save the duration of the project up to 2 months. BIM 5D output can be used by the project manager to control the project budget by reducing material waste. There is an efficiency up to 12.11% in dominant structural work. As for the dominant architectural work, there is an efficiency up to 8.02%, and for landscape there is an efficiency up to 4.06%. The MTO produced by BIM is then corrected with the volume of BOK and QS to determine the volume used. Then the results are sent to QS and also procurement or cost control. From QS will produce mutual checks and progress reports. As for procurement or cost control, it will generate a list of pre-orders, invoices and claims. In BIM 6D there are two analyses used are solar energy and engineering analysis. Solar analysis is used to optimize windows wall ratio to determine natural lighting and average electricity demand. Engineering analysis was carried out to check the strength of each structural element, and in checking the geoconservation roof, there were several elements that overcapacity. On BIM 7D, we input some information to the 3D models which is equivalent to load 400 for the construction phase, and load 500 for the as-built model. With CDE we can do coordination between stakeholders on the construction process. Distance between owner and other stakeholder is not an obstacle to transfer information flawlessly. We integrate our data as digital twin in an online platform called GIS Dashboard. In this dashboard, stakeholder could monitor the project progress easily and do an online site visit, especially during pandemic. Internal web based on QR code and embedded with BIM technology so that the process of exchanging information to the field does not experience distortion of information. Also by using augmented reality is to provide an overview of what the result of a building will look like.
Target on budget can be done by performing clash detection at the beginning of the implementation, thereby reducing the risk of rework, which increases the cost of work. Quality targets, obtained from the implementation of clash detection to prevent rework. Target on time, must also consider the risk of a clash which has the potential to increase time for work that has no effect on the main work. Ease of submitting approval of materials, shop drawings, and supporting documents regardless of the distance between the stakeholder. The selection of the most suitable work method so as to get a time efficiency of +2 months and an efficiency of the dominant item of 8.06%, can save 0.42% of the total initial budget due to potential rework caused by clashes between elements, capable of quickly detecting potential overload in elements and also detecting quality improvements such as airflow or lighting levels. Use of new methods or technologies such as QR code to reduce distortion of information so that work can be accelerated and reduce waste such as paper waste.